Good morning, Steve Case here from Semantic Arts, and welcome to day 2 of the Data-Centric Forum. I'd like to introduce Brian Platz from Flurry. He's going to be talking about extending RDF to include both time and truth. So Brian, the floor is yours and the microphone is yours, so take it away.
Great. Thanks, Steve. It's great to be the first presenter today. I hope we have a good audience that's ready. It's really weird, I think probably for everyone, that I'm presenting. Steve's introducing me from, I think a spare room in his house or something like that. Quite a contrast from the event last year. And I'm certainly optimistic that next year will be kind of back to normal. As Steve mentioned, I'm here today to talk about truth and how we represent that in data. And I'll talk a little bit about why it's important, what some of the new models are for extending and decentralizing data, why truth becomes very important to those models, also why we need to think about truth as it relates to things like AI and AI accountability or AI ethics. And time goes along with truth. So an assertion and a triple, if you will, might be that I'm 24 years old. Well, if there isn't time associated with that, you can't call it a fact. So therefore, a fact without time is not a fact. So I was 24 about half of my life ago. I'm now 48. But that would have been a valid triple, but without the context of time, it is not valid. So time becomes a very important ingredient to this, and it starts to solve a lot of problems as well. I'm going to share my presentation here. So hopefully everyone can see what I am showing. So the first thing we need to kind of step back and look at is why truth is important. And ultimately, this is the vision. This is the vision that I want to see. I think probably a lot of people here want to see in their lifetimes, which is a true data web, data ecosystems that exist and connect to other data. And the thing that at least I like to think about is that we need to draw an analogy for this whole ecosystem to actually work to the web of pages, the internet as we know it today. Because the data web is going to need a lot of the same things. They're both going to need apps. There needs to be a Google for the data web, which is a place you can go and locate data instead of locating web pages. We need to have security wrapped around data. Just like you have to log in to use Salesforce or your accounting software or other, Slack, because you only can see data related to you, we need those same kind of notions of how do we authenticate and authorize across these networks to make this happen. And then the infrastructure layer needs to be there to support it. So we need infrastructure as a service, kind of like Amazon's AWS, but for data. So instead of renting CPUs and computers, we need to rent data and data delivery and analytics and query capability. We also need things that are parallels for the infrastructure, like source control. We can't really build web apps that exist on the internet today without source control. At least we can't do it if we're collaborating with anyone. And therefore, we can't build data ecosystems without this ability for source control, so that we have a common reference. We can never agree on truth if our world's constantly changing and we can't lock in time to do that. So that becomes a very important thing. And we also need these strong concepts of trust and identity, like we have on the web today. One of the analogies I would give for each of these is the little green lock that comes up in your Google browser when you're on someone's website that proves that that data is authentic and hasn't been tampered with and came from the source you think it's going to come from. Well, the data web needs that same green lock, but of course it's a machine-to-machine interaction, so machines need to be able to validate that green lock as well. And we need concepts of identity, but instead of logging in with usernames and passwords like we do for most of the web apps we use today, We need a more secure, might as well be more secure, because it's going to be a more direct machine-to-machine interaction. So a lot of these things we need solutions for. And again, I'm just going to focus on a slice of these here today, which is the concepts around time and truth. So to set that context up at a high level, we'll talk and draw a contrast between an application-centric and a data-centric environment. So we're huge advocates, as I think probably everyone in this community is, of becoming more data-centric. How much do we need to be data-centric? I mean, that's something that I'm not a zealot that thinks everything needs to move to that model. Just like not everything needs to move to, Amazon EC2 instances, there's still a place for mainframes. But I sort of think about an application-centric model the same way I think about mainframes, which is, there's certain things that are just isolated and need to do what they do and do it really well. And those can and probably should sit in an application-centric model. But a huge part of our data, I think, will never be unlocked for its potential until we move it to a more data-centric model. But these models bring up very different challenges. So I just lay out a couple of the things or how we can make a contrast between these models. One is how we interact with the data source. Well, in an application-centric world, it's one-to-one. There's always one producer of data, and there's always one consumer of data, which is the application that sits in front of it. So that's a very, very different world than a true data-centric model that can fit into this data ecosystems. Because here we have a many-to-many. There may be many sources updating data, many applications, maybe even individuals outside your organization transacting data directly into data that you're maintaining. And of course, there's going to be many consumers of that data, many different applications, whatever the case may be. When we think about security model, in an application-centric world, the security is coded into the application server. And this is fine. I mean, if it's a one-to-one model, the only thing that's talking to my database is the app. So whether the security is sitting, with the data or with the app, it doesn't really matter. There's only one path to the data anyway. But in a data-centric world, we need a data-driven approach to security, co-resident with that data. And I think I originally maybe stole it from Dave McComb, this idea of data defending itself becomes very important. Capacity, it's a very centralized in an application-centric world, centralized fixed capacity. You have a lot of control over how it's getting used. If you're metering capacity at all, typically you're doing it ahead of the data tier. You're doing it in your applications. But in a data-centric world, capacity and demand could come from anywhere. So I don't no longer have a lot of control. There might be some organization outside of my company. Maybe I'm a retailer and it's part of my supply chain that's trying to get some sales data so that they can then do their own planning. I don't necessarily have as much control over where that demand is going to come from on that data and how it's going to happen. So thinking about how we decentralize and have more dynamic capacity around data becomes very important. And when we think about analytics, especially across data sources and AI in an application-centric world, we're stuck in our typical paradigm, which is our ETL, get our data out, jam it into some big database, so data lake, data warehouse. And then, of course, we have to re-implement the data security because, again, it was in our app server, not with our data. And usually people don't do this last step. They just limit who can see the data in the data lake to those who can see everything. But those are all the steps that need to be done. And of course, this just needs to be natively handled in an effective data-centric environment. And when we think about external data consumption, so people need access to my data, our one big hammer for whatever the sort of thing we need to pound looks like is APIs. And of course, we build them custom at significant cost. A lot of that cost actually isn't in the initial development, it's maintaining it over time. And I think the sad thing about APIs is it's not only a cost that we incur on ourselves to build it, but we impose a even more substantial cost on our customers, the people who need that data, because they now need to write custom code to integrate with our custom APIs. and every consumer needs to do this. So it really magnifies. There's a tremendous amount of expense in here. And if people don't properly allocate to maintain these APIs, this is where a lot of the security breaches come from. In fact, recent Akamai research around financial services now said that 73%, I think it was, of all data security breaches are happening at the API layer. It's because that's where the hackers are targeting, because that's where they know the vulnerabilities are. So it's a real commitment and cost to maintain this in a secure way. But in a data-centric world, we can really focus on standards-based interfaces where we don't have to build custom APIs. So when we think about data in these ecosystems or participating with data across boundaries, and I'll use that word boundaries loosely. I mean, I think in an ultimate world, we're talking about across organizations and different entities. But of course, when we talk to a lot of large organizations, they have a lot of boundaries just within inside their own company. Different departments, maybe different acquisitions they had, and these needs of creating sort of master data management, master data services across these organizations sit. So these challenges exist in a lot of places. But as we think about data getting distributed, we also need to think about a trust model that supports it. And there isn't like an ultimate trust model, in my opinion, that exists out there. There's different trust models that apply to different situations. So that's one of the things we'll talk a little bit about. And I know we got off to a late start, so we'll have some abridged time here. But we do have, I think, 30 minutes of Q&A available after the session to dive into any of these topics in more detail. So it's interesting when we look at this trust model, I always like to reflect back on the semantic web layer cake that Tim Berners-Lee put out in 2016, which is quite some time ago now, I guess 15 years ago now. But there were always these boxes there. So there was an acknowledgement that these were going to be some of the challenges. There just really weren't a lot of good options to think about how to address them. So they're kind of like these open boxes: crypto, proof, trust. And we've seen a lot of things in distributed ledger technology, blockchain technology, a lot of advances in decentralized computing that are really starting to fill in some very good models for these ideas. So in this diagram, the one thing I wanted to talk about when we think about trust is these different models of decentralization. So when you have a centralized database, SQL Server or MySQL sitting behind your application, the trust model becomes much less relevant. Again, you're usually coding the trust model by hand into some programming language, which is sitting in an application server in front of your database. That data repository isn't really getting exposed to anyone except for that app. But when we start thinking about sharing data, and again, this might be within different groups, within the same organization, this might be cross-organization boundaries, we can start thinking about distributing that data out, or data exchanges. In here, the ideal trust models revolve around identity management. So who are each of these entities? And typically public-private key cryptography. And the big advantage over public-private key cryptography to identify yourself or identify a machine or an IoT device is that you never disclose a password. So it doesn't matter how many times you interact with or how many entities you interact with, you're never giving anyone a password. You can use that same core identity to always prove you're you without ever disclosing a password, because you maintain your private key. The only thing anyone else sees is a public key, which is why this type of cryptography is used so frequently. And then all the way out here, which is an area that we've been doing a lot of work in lately, and I'm really excited about, because it's almost mind-bending as far as how this changes data, is the ideas of verifiable credentials. It's the ultimate decentralization. It's the decentralization where the data doesn't even sit in a central repository. It sits, in a data wallet, a credential wallet on my iPhone in the individual level. And of course, this is going to make sense for certain types of data, but it's the ultimate in giving people the control over their own data, who sees it and where it's sitting. So there's, of course, a lot of excitement around the education space for this and representing, digital degrees, digital transcripts that are verifiable. There's a lot of work around this with Department of Homeland Security around, ideas of like a passport, a digital passport. But when we look at this model, these are typically secured or ideally secured in the context of a verifiable credential. And a verifiable credential supports decentralized identifiers. We even have the potential in this model to get into decentralized authorization, which is cool, meaning you do not actually need to maintain information about a user at all. They don't even have to have an account in your system, but you can say someone can view this data, if they're a US citizen and if they attended a 4-year university and if they have a GPA greater than 3.0. And never know anything about the user, but actually be able to get all that proof from authoritative sources when someone tries to utilize that resource or get access to that data, and be able to release that data with the confidence of not actually having to have someone like log in with a password or even knowing who that person is. So really neat things on the horizon there. And we're not going to have a lot of time to talk about that today, but again, in the Q&A, happy to talk about that as much as we want. So trust and truth, what's it look like in data? So ultimately what we want to get to is some level of data provenance and data traceability. So there's two pieces to this puzzle. One is on the provenance side, we need to be able to prove concepts of time and identity around information. And then at the other end of it, we need to be able to apply permissioning dynamically based on data we have in the repository. Who's allowed to update data and under what condition? Who's allowed to view data and under what conditions? How do we think about that and embed that into the data tier to make this possible? So I'll skip through a couple of these and we'll get to how we particularly look at this problem. And I'll also make a contrast here or a reference to RDF star, because I know that'll be a question that some people have when it comes to what I'm about to explain here. So if we're looking at a triple, subject, predicate, object, if we want to add a notion of time to it, we have to add an extra element. So that element itself, at least how we model it out at Flurry, is just a pointer to another subject. But it's a atomically incrementing pointer. So it's works independent of sort of wall clock time or any relative time. It's an internal clock of updates happening to an immutable ledger. So we start thinking about triples instead of being like a set of data representing some information that has no time attached to it. Starting to think about them as a log. And in that log, we're constantly appending to it of changes to triples that are happening, the deltas as they're happening. So the first part is we need a reference back to the transaction that put that triple in there. And the idea is when I issue a query and I get data back from my Sparkle query that all originates based on certain triples, I should be able to look at any piece of data that comes back in my query and say, who put that data in there? When was it put in there? Prove to me that that data has never been tampered with. And those are all things that we can natively embed into this model, into the ledger. The next thing we need to do is when we have time, we have this concept we have to address of assertions and retractions. Are we adding or deleting data? And so we need, and in this case, we use just a Boolean identifier, true or false, that we add into the triple to indicate a true, meaning these are new facts, new things that are coming into the ledger as of this moment in time. A false would indicate these are old facts. These are facts that were in the ledger up until this moment in time, but now we're retracting it. We're saying it's no longer true. And what we want to do is we want to layer time travel on top of the query. So when I issue a Sparkle query, I can say, just give me what you know currently, but I could issue that same query and say, give me the response as it would have been on January 1st at this exact moment in time. And this data we have here is enough to allow us to do that. Of course, a lot of work needs to be done under the hood to create efficient indexes that allows this sort of traversal of time. But just by adding these two elements, we could do that. Now, could we represent this in RDF star? Yeah, technically we could. It's quite verbose, RDF star. So internally, to make things efficient, we're going to represent it in a different way regardless. But the time is this idea of adding or retracting, whether something is true or false. Typical RDF only has a notion of true, like you only have a triple if it actually exists, if it's a true fact. So we need to actually think about them differently, in that a triple can actually be a retraction as well. And I know I'm about out of time, so I will really just, I think, conclude here. The other part that I can talk about a little bit more in the Q&A is this idea of smart functions. So how do we traverse relationships to determine what people can do, what data they can modify, dynamically filter out triples that they don't have the ability to see, and happy to get into some of that as well. And with that, I will stop, and I believe our next step is to move over to the Q&A session. So thanks for attending, and hope you enjoy all the presentations today.